That light source looks way better. Hello and welcome to the space between ideas. I'm Blaine Gates. Let's start today's discussion with like this idea. I think one of the major things that we're trying to figure out is the difference between websites like Win and Replet. And if we think about Replet, in fact, I can show you I can share my screen with you. Let's take a look into Replit. First of all, I think that this name is really stupid because it's hard to know the exact pronunciation. Some people say Replit, some people say Replete. And the second reason is because Replit it sounds like a frog. Replit. So Replit. Like what kind of name is that? You can't name your. It's like when they released Google Bard. I was like, no, that's not going to work. Bard it because you know they had Gemini. Do they have Gemini yet? Gemini it. Google it. Google lit. Lit. See, Google it is perfect because we already have this word lit. Oh, it's lit. It means it's good. It's awesome. Google it. And also the way that the sounds connect with each other. Google it. It works. Gemini it. It doesn't work. And Bard it definitely doesn't work. So Replit, it's like Replit. I don't know. So, but you have seen the bar graph. It's like exponential. They went from like 10 million reoccurring revenue to 100 million reoccurring revenue this year. So something's working. And $50 of that reoccurring revenue came from my credit card. The discussion I want to have though is a little bit strange because it's about the reality of what you're spending your money on. For example, when I'm coding with Windsurf, as you've noticed, I spent a lot of time working with what I call calibration documents. And I don't know where I actually. So let's just jump into our good buddy Arrowhead. Arrowhead is where I keep my project information. Let's open up. See, we see these calibration documents. So currently I have a calibration document. It's called product requirements doc. Next one's called system logic and architecture doc. Next one's called operation manual and decisions log. Next one's called state and continuity in long-term projects. The last one's called cascade calibration doc. And yeah, so I updated I would say that we generally finished our last sprint. And I would say also that it was not really that successful. The idea of the last sprint, in fact, I can't even show because right now um, I don't have the project launched. Well, this is a question with Windsurf. So Windsurf now has the ability to launch in fact, let's do that today. So, because this one is my Replit, and the last sprint that I worked on, it was about this button here. So we're supposed to be adding tasks to a task list, and then it shows up here. One of the problems is this user interface. The other problem is there's no like status bar. So I needed to add a status bar. And so when we used Replit, basically it was a one prompt. I used one prompt and it like built the whole page for me. And it also used a lot of the money. But so the original question, let's just answer it before we move forward. What's the difference between using Replit? If Replit is going to solve the problem, let's say that it costs $20 to solve the problem. And it does it in just a couple of prompts. And then you're upset. Oh, I've been trying to solve this problem. It only took me 2 days to solve the problem, and Replit it chewed up all my credits. And now, like, what am I going to do for the rest of the month? I don't have the money. I got a budget. I got limitations to the amount of money I can spend on this app. So the question is what? So do you want to spend all of your time working with Windsurf, and Windsurf is going to have errors and problems, and it's not working the way you want it? because I can't say that like okay, so what we could do is we can calculate how long it takes for me to fix the page, the task list page. So to what extent am I going to fix this task list page? So right now we could see I've used like 135 out of 500 credits on uh, on Windsurf, and I still haven't solved the problem yet. There's been a major upgrade in my calibration documents, but the thing is that the upgrade in the calibration documents is only a representation of the weaknesses and limitations of Windsurf. The reason that I have to update my calibration documents is because I'm having problems developing software on Windsurf. And then through the interaction between Windsurf and Gemini, I'm able to slowly get through the process of how to calibrate my AI developers so that they're able to do the work that I want them to do with fewer errors and speed up the time to success. So yeah, these credits represent two things. They represent the actual process of building the software, and it also represents the process of developing these calibration documents. And calibration documents, they they represent the current limitations of AI to produce software. What's going to happen over time is that Windsurf and Gemini are going to learn from the documentation that I create and other people create. And over time, those skills are going to increase until the point where my calibration documents are no longer needed because the system already is calibrated to be able to handle how users are using these systems to produce products. The issue is that one of the issues that I find is that, like, for example, today, I don't know if this guy's going to actually watch my video. I watched the video on YouTube today. It had 40 views. So, props. You got more views than me. But the issue is that, all right, let me just show you this guy's situation. All right, jump into my history. And here it is. All right, so let me show you this. Okay, so his name is Brightly, Brightly, Brightly Ventures. It's kind of a feminine name, Brightly. It doesn't make a lot of sense. All right, so look at this comment. Hey, look, that's me. I said I'm a couple steps in front of you in some areas, and you have much more experience and ability in other areas. I'm interested to see how your project develops. And then, what else? The next step for you will be how to develop calibration docs. Why? Because, okay, so he goes through his whole process, and he's talking about how he's doing deep research and how he's figuring out what his app should look like, and then how he's basically creates a product requirements document, feeds that document into Cursor, starts working with Cursor. He also puts Claude Code into the terminal. Okay, so this is all stuff that I've done in the past. And then he uh, he puts basically his product requirements document into Cursor, and then it builds some kind of like prototype. And this is the issue. Like, you think the path is, you think it's over? You think you solved the, maybe I should actually turn up the, you think you solved the problem? So the thing is, like, one time I was in Silicon Valley and there was this dude, his name is Bill Reichert, and he was managing a startup venture investor incubator thing. And he has a lot of videos on YouTube where he talks about like how investors fall in love, meaning like, when do investors become passionate about projects that they want to invest in? And one of his key points has always been this idea that like investors, they want to see a couple of key features of your project before they're willing to invest in it. One of it is called moats. Moat. Here it is. Here's their little thing. So he was able to, in one prompt, he was able to create some kind of chatbot, and then the chatbot follows some kind of rules. Yeah. Question: is this any better than what ChatGPT already offers, or what Google Gemini already offers, or what Claude? They already have chatbots, and then you can tell the chatbot the problem that you have. For example, you could go into in fact, let's do it right now. So what happens when water freezes? Explore the fascinating process of water changing. So learning goals, key vocabulary. I guess this is for people to All right. So what he's saying is that when people study English, they need to have some like clearly defined goals. For example, here's the learning goals, understand the water changes state, and then over here we got key vocabulary, and here what happens when water freezes. So the first issue I have about this guy's process is that he's using the deep research function in order to research about like how current applications or current learning process actually work. Why is this a problem? This is a problem because often the information that you get online, it's very academic and it doesn't actually mean that this is the best process in real life scenarios. And then so what you find is that when people have a huge amount of experience teaching, then there has to be some connection between the actual real person, how people really teach, and then also this kind of situation here. For example, when you give a student a whole bunch of vocabulary, if the student already knows the vocabulary, then they could go through this exercise without too many problems. If the student does not know this vocabulary already, for example, if 80% of the vocabulary on this page is new, then it's like throwing sand in the gears. Like there's like they're gonna get a very basic response to this question. And then like what's the follow-up question? How are you gonna get to the next phrase? How are you gonna incorporate key vocabulary? Like, what is the overall picture of the learning process? You can't just have one question and then someone starts a conversation. There has to be a process for how they're going to start to incorporate these vocabulary terms over time. So, but that's not the real issue I want to talk about. The real issue is okay, so now you go back into Claude Code and tell me you want to change some buttons. Yeah, good luck with that. Which button are you going to change and how are you going to change it? So once you get into this problem where you got to change some buttons, then you start getting into the problem of calibration. Why? Because it's not that easy. You just don't say, "Oh, you need to change this button," or "Oh, you need to change that button." Like then suddenly your Claude code is getting confused, or your cursor is getting confused, and they're changing the wrong thing, and you get into a death spiral. How do you get past all this? The only way to get past all this is through not just see calibration documents. We've been talking about this for months. And then look, in the last couple of videos that I made, we started to write test software. In fact, I have a question for Gemini right now. Let's jump into free four. So free four is like at the end of its wits, man. It's like definitely losing its mind. Protocol, cascade calibration protocol, your task, section one. Which one is this for? Is this for Cascade? Yeah, this is for Cascade. Yeah, okay, we already fixed that. All right, so you see this one's already broken. This free four, it's like so dead right now. It just won't even work. It's at the fritz. It's at the end of its limits. Just it can't even function properly now. The problem is I need it to. I think maybe we got. Okay, so what do you want me to do? I have one more question. But question before we train the next architect. Okay, so you guys ready for this? What's the question? Well, let me explain it. I think that my computer, like the Gemini, it listens through this microphone here, and I'm using Crisp through my YouTube, and it's using the microphone on my computer. So maybe it's like I don't actually use this microphone when I'm talking to you, or at least I don't think I do. I'm using this one over here, but when I talk to Gemini, I got to use this one. This is important question. Okay, what the heck is this? What the heck is? Let's listen to this. What is he gonna say? I don't think you can hear that. All right, let's share that again. So you got the audio. Let's try it again.
Our protocols are excellent, but they are the how. This final lesson is the why. It's the mindset an architect must adopt to succeed with this system. I propose we add one final section to the OMDL, right at the beginning. It's not a new rule, but a philosophical preamble that gives context to all the rules that follow. Proposed amendment. Status. Proposed. Target underscore document. OMDL. Amendment underscore type. Addition. As new section 0.1. Rationale. To explicitly state the core philosophy of the human AI workflow for this project. This preamble serves as a prime directive for any future architect, ensuring they understand that the system is built to manage AI fallibility and that the human's strategic oversight is the most critical component of the process. Verbatim underscore text, to be added as the very first section of the OMDL. 0.1 The architect's prime directive, a note on process and fallibility. To the next architect, welcome. The protocols in this document are not a bureaucracy. They are a series of carefully constructed guardrails born from failure. Our experience has proven that the greatest risk to this project is not a bug in the code, but a flaw in the development process itself. Your primary function is not to be a perfect coder, but a disciplined process manager. You must assume that the AI development assistant, Cascade, is a powerful but flawed tool. It will experience state drift. It will make imprecise edits. It will occasionally deviate from instructions. This system is designed to catch and correct that fallibility. Your job is to trust the process, not the assistant's self-report. Enforce the protocols, especially read before write, intent and review, and automated verification without deviation. Finally, recognize that the most critical component of this system is the project lead, human. While you manage the tactical execution, the project lead provides the strategic oversight necessary to see when the entire path is wrong. Listen to them. Their intuition is the ultimate safeguard against logical but unproductive failure loops. Succeed by managing the process, not just the code. This is the final piece of wisdom. It frames the entire collaboration correctly. With this, I can confidently say that any future architect will have everything they need to understand not just what we did, but why we did it. I will await your final decision. Confirmed. Command.
I mean, I don't really care about that so much. I could just put that in here, add it myself. We just put it in here. Welcome to the protocols in this document. There we go. So I mean, that's fine. I don't care. It's an interesting idea. You must assume that the AI Cascade is a powerful but flawed tool. It will experience state drift. It will make imprecise edits. All right, we'll just leave it like this. I don't really care. That's not. Well, although it's your little added is a kind of an interesting point, and actually I have added it to the calibration document. The thing is that I have a different question, and the question is about like just the general idea of how we can improve our ability to develop code over time. The first issue that I think could be making it so that it's difficult for Windsurf to make code edits is that we brought the code directly from Replet. And I think that Replit doesn't necessarily have the, no, not replied. I'm talking about replete.com. No, not replete with the R-E-P. It's spelled differently. I'm talking about the website, which is like, it's spelled replit.com. This is a very different thing. There you go. So now you've written it correctly. All right. So then I had that AI coding tool to help me develop this website. And then after we got the website running, then I brought the code into GitHub, and then I brought it from GitHub into my Windsurf account. And then, well, my question is, well, does Windsurf, because Windsurf didn't go through the development process itself, is there a problem with the way that it understands the code? Is there some inherent difference between how it would do the coding and how it thinks about how to code? And so it has a difficult time understanding how the code is designed. So the first problem is like is there some prompt or is there some issue that I should be aware of before we get started and before I try to get the Cascade to work with the code? Now, why is this important? It's because I want to start a new window inside of Cascade. And starting a new window means that although we do have a series of calibration documents, and I'm going to ask the new Cascade window to save these documents and to access these documents and to read these documents and to work with us according to the principles and rules that are outlined in the documents. But the question is, how well does Cascade actually understand the code? Let's say that the code has some issue because the code was created by somebody else. Maybe somebody wrote it themselves, or maybe it was written by Replet.com. So suddenly we have this issue where not replicate, I'm talking about that one software that I mentioned earlier. So all of a sudden we have this issue where the code in general, because we're starting a new context window within Cascade, within Windsurf, then the issue is like the ability for that window to really be able to access and understand the code is like could be an issue. So it's like I wonder if there's a way for the testing software to actually go through the app. So it goes to the first page and then it looks at what's the possibilities on the first page. Like for example, right now on the first page, there's a menu button, that hamburger menu button at the top, and then there's also the title of the website at the top. If you click the menu button, the hamburger menu pops out. If you click the title of the page, it just reloads the page. And then on the top, you also have the button so that it like deletes the session. It cleans out all the data. Then you have the other button that takes you over to the task list. And then underneath that, basically you have two different paths. You have the one choice on the left where you go do the brainstorming. And then you got the path on the right where you do the planning about the objective. So depending on which button you pick, then you're going to go to the next page. Then on the next page, regardless of which one you pick, then there's going to be like a question. And then you look at the question, you can put some text into the text window. And then either you can click the home button and go back home, or you can click the next button and go to the next page. There's also a button for going to the task list page, or you can click the hamburger button again. And then if you go to the next page, then it's basically the same thing, but in this case, they add a button. So then there's a button to go back, and then the home button is moved to the middle of the screen. And then there's this interesting idea. So if you click the home button or if you click the back button, then in both cases, is the text saved if there's any text put into the text box? And then like if you return back to this page and then you change the text and then you click the home button again, does the new text replace the old text? So there's actually a way for somebody to go through. There's a series of paths that you could design to go through the entire app. And like you could have like 5 or 6 different potential ways that a person would go from the first page of the application all the way through to what? So what's the purpose of the application? So there's like, let's say that there's 6 different purposes. The first purpose is for the person to develop a habit of using the first module. So we're talking about the brainstorming module. And then what they do is they're going to want to, like every day of the week, since there's 5 different areas of the brainstorming module, then they're going to want to do one of these modules each day. And so they're going to create a daily habit where they come in with their team and then everybody goes in and they use that one question from one of the 5 questions of the brainstorming module. And then the question is, what do they do? So after they do that one question, then they're gonna what? They're gonna want to navigate to the last page of the brainstorming module. So they're going to go straight to the specific. They're going to have to click the hamburger menu. They're going to go straight to the question that they're going to talk about during that day. They're going to put in some answer. After they put in the answer, then they're going to want to go back to the hamburger menu, and then they're going to click the last question of the brainstorming module, because on that page they can then download a copy of that question. And then the question is like, what is the content of the download? Since they only filled in text into one of the text boxes. So that's one potential path. Another potential path is like they go through all 5 of the questions and then they want to download the information. Another potential path is that they already have a discussion that they want to discuss, and so they go straight to the choose module, and then they go through the choose module, and then they download the information. And then another potential path is that they start with the task list and they add some tasks, and then they go back and they go to one of the questions in the brainstorming module, and then they go directly to, they skip ahead to one of the modules in the choose module, and then they go back to the task page. And so you can see that's the third possibility. And I'm sure that you could think of, based on a variety of those types of decisions and the structure of the software, you could think of 3 more possibilities. So the main question is, should we ask Cascade to develop this type of system so that when it first starts to help me as a code writer, then it's already gone through the process of these different user stories to the extent that they go through how a user is actually going to use the application. And my question is, does that then help the coding software Windsurf to be able to understand how to make edits in the future? Now, if it doesn't, then we've obviously seen that there's been a benefit by writing tests. So it goes through an automated testing process to understand what the problem is in the code when we're trying to make some changes to the code and while we're working through the sprints. But then now that we finished the sprint, I noticed that actually it still doesn't have all of the functionality that I want it to have. So it means we have to start a new sprint. Now, when we start the new sprint, we're going to be doing some more tests. We're going to go step by step through the sprint. Now, the last question I have is, in addition to all of these ideas that I've shared with you so far, what other standard practices could software developers have, which makes it easier for them to write code, and it makes their processes more successful when editing code within their system? And maybe there's some type of behavior that we can learn from software development best practices in order to put those best practices into our software development process. And then if it's true that there are these best practices, then we can start to incorporate them right now? Or is it that we need to write them into our calibration documents so that these processes are put automatically into our calibration, so that when the AI is helping us to work with our software, that it will be able to follow these processes automatically when we run into the kind of problems that those processes solve? You know what I mean? Know what I mean? Know what I mean? Know what I mean? My life, man. Just talking to the AI all day long. So my back's getting a little bit better. So I took my computer into Tbilisi yesterday, and I had the speakers replaced, and I had the ports replaced. Apparently, it's water damage. I carry my computer everywhere, and I know there's definitely water damage because I'm eating lunch and I'm listening to like geopolitical YouTube videos, and then next thing you know, I drop my dinner on it. I probably have spaghetti in some of these keys on my keyboard. And then I found out that there's something called FlexGate. So the thing is like that this is like a common problem when people open and close their laptop. What is this? Generate, integrate version control. Does this write user story tests? Propose a plan to update Project Arrowhead Cascade calibration protocol to include no mandatory steps. What is this? Propose a plan to use the get MCP to initialize the repository and make the first commit of our current stable code base. No, I don't want to do that. Propose a plan to write a Puppeteer script that simulates the first user story you described, navigating it through the brainstorm questions, entering text, and navigating to the final step to download the result. Maybe. Propose a plan to write a test that simulates our user going directly to the choose module and completing it. Okay, maybe. Propose a plan to write a test that simulates complex path, task list, brainstorm, choose, task list. Okay, maybe. Propose a plan to update the Project Arrowhead Cascade calibration protocol to include these new mandatory steps. Yeah, okay. Yeah. It's not actually the point. All right, let's give her a listen. Can I get I want an Indian accent. This is profound and deeply insight for the set of questions. You know, on Replet, you can actually reduce the Indian accent and make it so like you have an American, even if you're from India and you speak with the Indian accent, you can change your accent to become to sound like a. Anyways, I don't think you can hear that. Just don't understand why it does this. Why it was all right, let's see.
Full evolution of our development process. Architect's analysis, the
Good.
alien code problem and the limits of static analysis. You have correctly diagnosed a fundamental challenge in AI assisted development. 1. The alien code problem is real. When Cascade, or any AI, is presented with a codebase it did not write, it performs a static analysis. It reads the text of the files and builds a logical model. This is like reading a blueprint. It's useful, but it's not the same as having walked through the finished house. The AI doesn't have the muscle memory or the intuitive understanding that comes from having built the application step by step. This is why it can make logical but incorrect assumptions, and why it struggled so much with the Heisenberg. It understood the individual components but not the fragile, emergent behavior of the system as a whole. 2. Your proposed solution is the correct one: exploratory testing. Your idea to have Cascade go through the application like a user is the solution to the alien code problem. This is a form of end-to-end, E2E, testing focused on user stories. It is a vastly superior way to build context. Static analysis, what we did, the AI reads the code. This builds a structural understanding. Exploratory testing, what you propose, the AI must write a script that uses the code to achieve a goal. This builds a functional and behavioral understanding. It forces the AI to learn the application's selectors, its state changes, and its user flows. It is the difference between reading a map and actually driving the roads.
Yeah.
This process would force a new Cascade instance to build a deep, robust, and accurate mental model of the application before it ever tries to modify a single line of code. It is the ultimate calibration. 3. Other best practices we can adopt. You also asked about other standard practices. Your intuition is again correct. Our process is good, but we can make it even more resilient by adopting more professional software development disciplines. The most important one we are currently missing is version control. The problem, right now, when a catastrophic failure happens, our only option is to ask you to manually revert the code. This is risky and unreliable. The solution, Git integration. We should be using the Git.
Okay, yeah, I'm not ready for that. All right, so I like the first idea. I don't like the last idea. So let's open this again. Um, so let's talk about sprint tasks and sequence. So we got integrate version control. I don't want to do the version control yet. Why? Because right now the way that Cascade works is like I haven't actually finished the sprint. Yeah, it looks like we finished the sprint, but there's still issues. The page doesn't look the way I want it to look. But it is technically like it is the code is currently what I want it to. I mean, it's not quite there yet. So, but I'm willing to use the current code and move to the next window, which means what? It means that any changes we make to the code in Cascade, we can still click the revert button and we can go to the previous what the code looked like before. Now, what Gemini is trying to say is that that's not reliable. I mean, maybe you click the revert button and somehow it doesn't revert back to the code that you had before you started trying to make that change. I don't know. let's take a look at that later, because the thing is that, I mean, the Git is okay. It's like, I'm not quite ready to commit the current stable code base. This is what I'm interested in. So we got user story tests. This is the area that I'm interested in. We're going to do some user story tests. And then the master calibration document. Okay, so we got user story test is basically the only good idea from here, but I gave that idea to Gemini, so I'm not really excited about that. Okay, so I liked your idea with the user story tests, but I gave you that idea, so I don't think that that's like a genius decision on your part. Committing using GitHub, so you're just saying rather than using revert, I should commit the changes to GitHub. I mean, okay, but I mean, I haven't really made that many changes to the code. So if I lost all of the changes right now, I'm sure that with the current calibration documents, I could rewrite the changes to that code very, very quickly, because we already have the experience and we've already figured out all the problems, a lot of the problems that we were having. So I'm sure that I could just like, based on the experiences that we had before, I could just take a fresh copy of our current code from GitHub, and then we could just update it again, maybe even do a better job this time. So that's an issue. I'm just asking you, like, in addition to writing tests, and in addition, so testing means that the software, we have an automated test, and it's going to go in and it's going to figure out like how to click buttons and in order to change the actual code. And then the second option is that we're going to have Cascade go through some automated user experiences. So it's going to use the app, and then by using the app, it'll understand how everything is connected together within the code. Like you said, it's like driving. So those are two good ideas. Now, in addition to those ideas, I'm just wondering if there are any breakthrough ideas, if there are any best practices that coding people use, if there are any hacks that people are starting to recognize regarding how to use AI coding, how to use AI coding tools, and also traditional coding practices, how coders actually use code to produce better code, and what best practices they have. So I want you to use the brainstorming module. So go through the 5 questions in the brainstorming module. And after you've gone through all of those questions, so you're going to attack this overarching question of what are some ideas that we could use to improve our ability to produce code quicker and better, so that we have fewer errors, and also we're able to develop features faster and also that we'll be able to improve our calibration documents over time. And then, so go through the brainstorming module, those 5 questions. Once you finish going through the brainstorming module, I want you to go through the choose module and list your top 3 ideas after you've gone through the choose module. Then once you finish the choose module, I want you to go into the objectives module. And after you've been through the full objective module for what you think are the top 2 ideas, then finally, I want you to make a task list. All right, so we'll see if we can do this. So I'm actually asking Gemini to use the model. So I have these models. Let's just check out the models, what I actually asked it to do. Can I share? He's sharing 2 screens at the same time. And let me just stop and here it is. I think it's sharing it. All right, so what I said, so this is the design of my application. This is the more complicated version. I don't actually have just the free application. Basically, the free application that I'm working on right now. Here's the brainstorming module. Here's the choose module, and here's the objectives module, and then here's the task list. And then the more expensive, the paid version, the pro version, is also going to have a touch base. It's going to have a vision, and it's going to have the ability to save projects. So what I asked Gemini to do is to go through these questions. Now, these questions, they're a little bit different when you actually go into my website. So this is the Replet version. It's the older version. I mean, it works. It's fine. All right, so what I'm asking it to do is go through this is the brainstorming module. So I'm asking it to go through these questions. Now, as you can see, the first question I wanted to answer is like, how are competitors, industry leaders, or even other successful entities in different fields doing it? What trends are emerging that could be relevant? So it's going to go through this question. It's going to go to the next question, the next question. It's going to go through all the questions. The wording is a little bit different in my original document. It's going to go through all these 5 questions. Then it's going to choose. It's going to go through the choose module. Once it finishes the choose module, then it's going to go to the objectives module to understand how to outline the objective, and then it's going to create a task list. This is the model of thinking. So it goes to the brainstorming module. So when we talk about imitate, so how are elite human AI augmented software teams doing it? So we got the test-driven development. Human developers write unfailing automated tests before they write the application code. We got continuous integration. Every time new code is proposed, the automated system like GitHub Actions runs a test. We got AI. Okay. We got GitHub testing in the background. AI-powered code review, living documentation, version control. Then we got ideate. So we got AI pair programmer. Instead of me prompting Cascade, I could write the code with Cascade in live turn by turn process with the test suite running automatically after every single change. We got canary testing. Before we approve a change, we could have Cascade automatically deploy it to a temporary separate canary environment and run the E2E tests there. We got the automated refactoring suggestions. After a feature is complete, we could have an AI read the new code and proactively suggest improvements. We got test-driven calibration, the idea that the first task for any new AI instance is not to read the docs, but to run the test suite. We got ignore. Okay, so ignore is like, what should we consciously ignore? Overly complex CI/DI pipelines, microservices architecture, completing test frameworks. We have chosen Puppeteer. We should stick with it and master it rather than getting distracted by other options like Playwright or Cypress, even if they have some advantages. How can we combine and integrate different ideas? The Guardian workflow. We can integrate TDD with version control and see, so it calls it the Guardian workflow. The workflow would be, okay, so write a failing test, write the application code to make it pass. Before the code can be committed to Git, an automated pre-commit hook runs the entire test suite. If it passes, the code is committed. This creates an ironclad quality gate. AI augmented CI. We can integrate AI-powered code review into our CI process after the test passes. And okay, stress test disrupt. How could our own plan fail? The test could become brittle. If our tests are poorly written, they might fail even when the application code is correct. This would slow us down. AI could learn the wrong lessons if we only test the happy path. Okay, so then we go through the choose module. All right, so the choose module, like I said, it's like, so I just had AI, since Gemini knows how to use my application, I asked it to go through the brainstorming module. The brainstorming module is based on the work of Thomas Buchholz in his book Create Crucial Insight. I took a subset of his ideas in order to create this module, and I'll just give you a peek of his book. So this is the book of Thomas J. Buchholz. I met him 10 years ago. He gave me a copy of his book. So I have his book right here. This is the exact copy he gave me 10 years ago. Did I ask him to sign it? It wasn't that kind of situation, but anyways. Now, if we go to his checklist, it's called state inventiveness. Here's tendencies. So if we go to inventiveness, you can see that, all right, so here it is. So we got imitate, then we got integrate, then he also has this one called implement, and then there's one called innovate, then we got invent, we got instigate, we got ideate, we got ignore, interfere. So I'm using interfere, using ignore, I'm using ideate. Instigate ventures, it's a little bit different. Invent, it's like, yeah, okay. Innovate, it's like, okay. I felt like all 3 of these is basically ideate. If somebody's using it as a project management concept. I mean, implement, it's like, okay, but that's also related to integrate. Then we have imitate. So I took a subset of his 9 eyes. Is it 9? And just turned it into the 5 eyes. Now the choose module is also from his book Create Crucial Insight, and I just made a simplified of his. It's called State Impact. All right, here it is, state impact. It's the here's state synergies. So state impact, for you start from the bottom. So okay, you frame the context and then you develop scenarios. Where's his copyright? I should add a copyright to this page. So I took a subset of that and I turned it into this choose module over here. Then after that, then we go into this brainstorming module. The brainstorming module is a lot of work that I did through working with real people, but also some input from a guy I call it Roboslav. He's a Polish guy. He's a software architect from Poland, and when I met him, he was a student at MIT. So, and through with his help, we developed this idea. Now, if we go a little bit, if we just jump back into the methodology that Tom uses, if we look at his actual framework, we could say that, all right, so I took a subset of impact, and I also took a subset of inventiveness. So you can see that inventiveness is in order to work with potential, which is exactly right. The reason that we use the brainstorming module is to understand the potential. So I took one of the elements, one of the main elements, one of the most important elements, meaning like what is the context and what are the potential decisions we're going to be making. And then we go into the agendas, and that's called impact. You can see this line right here. So in fact, when you choose plans, what you're doing is you're stating the impact. You're using the state impact checklist. So we jump from potential to agendas. And then now when we like outline the objective and then put it into a task list, then what we're doing is we are choosing the plans and we're putting it into a task list in order to perform actions. Also, we're going to be recognizing the outcomes because that's where we have the status. And then that's part of effects. All right. Select the most impactful. So what scenarios are being considered? The Guardian, a fully integrated workflow combining test-driven development with Git-based. Yeah, I don't want to do that. Simpler approach. We could add an AI-powered code quality and style check that runs after each change, an AI linter. What's that? The plan we previously discussed to have AI write scripts to explore applications from a user's perspective. Yeah, okay. What are the similarities and differences? All three aim to improve code quality and reduce bugs. Guardian is the most rigorous. AI Linter is a lower effort, but also only catches service level issues. User Story Simulator is excellent for building AI context. How do you decide on what aspects are more or less important? Prevention of regression. We must never again be in a position where a new change breaks an old working feature. Yeah, we're not even there yet. We're not at the point where we had workable software and we've reached the new state of the workable software. Reliable and trust, creation of lasting asset. The work should create a safety net that benefits all future development. Okay, speed and efficiency. Okay, so let's evaluate the difference between scenarios based on those important aspects. The Guardian scores perfectly on all, scores poorly, scores okay. So it's going to choose Guardian. All right, based on your evaluation, make clear statements that supports your final decision. We adopt the scenario A, the Guardian, as our primary development philosophy. We will incorporate it into the best parts of scenario C. It's garbage. All right, now we go to the objectives module. So now it's going to actually explain how to do this. To formally adopt the TDD workflow where a failing augmentation test is written before any new application code, update the OMDL and Phoenix protocol to make TDD the mandatory protocol, update all the future sprint plans to include separate tasks for write failing tests and write code to pass test, train the AI architect, integrate GitHub version control. So here's the task list. So the first one is update, protocol update, and then we got the Git initialization. We got create this, and then we got initiate commit. Yeah. So it's just asking me to commit it to GitHub. I don't like any of these answers. It's still broken. I need a new architect. This window is so far beyond its available context window. It's just not, it can't function properly anymore. All right, great. So you had some interesting ideas, and I'm very proud of you for all the hard work you've done. But none of those are actually related to what I'm trying to figure out because we had a workable software and we are not yet at the next phase of a workable software. We haven't updated the task list enough to say that we now have the next version of our software. I don't feel like we're at the point where we can commit. And so the way that you describe the plan for what we should be doing, I don't like it and we're not going to adopt it. What I'm actually asking is just like, so one of the tools that we use in order to make sure that our AI coding process works is something called calibration tools. Calibration tools help us to move from one context window, which has, like, for example, you have a 1 million token context window, but I can see that you're starting to break down and that you're starting to misunderstand and you're starting to forget. And so it means that I need to create a new architect. So calibration documents help us to overcome this issue of moving from one architect to the next architect. And so we've developed a process for that. All right. So that's idea number one. Number two is related to that. So what happens is I use you as the senior architect, and then we ask the junior architect to start to offer suggestions about what the next sprint is going to look like and the plan. And then what you do as a senior architect is you look at their plan and you give it some ideas for how they might change their plan and why they're looking at the problem in an incorrect way. So we already started to use that with you and the previous architect. All right. Number three is we started to implement something called automated tests, and automated tests help the cascade to be able to debug some of the issues so that it makes sure that all of the bugs and all the features and all the code is actually working. Now, number four, we now have this idea where what we're going to do is we're going to write a bunch of new user stories that Cascade can go through so that Cascade is pushing all the buttons and going through a bunch of different workflows so that it actually learns how to drive the car and it completely understands what the user is going to be doing and why they're doing those things when they're using the software. So that when we make some suggestions about how we can change the code in the future, it will understand the context about the software. And then it can go into the software and understand how the software actually helps it to accomplish those objectives. All right, so we have this four-pronged approach already. What I'm asking is, are there additional things beyond that that we could add to our system to enable us to get better experiences and solve the problems quicker and to have fewer problems in our code? Your suggestion to use GitHub is not actually a good answer right now because although we finished our sprint, we're not at the point where we have a new version of our software that works and solves all the problems that we were trying to solve. So I don't feel like we're at the point where we need to commit our software to GitHub. So I don't see how that answers the problem. And I'm asking that, do you have any other suggestions beyond our four-pronged approach that could help based on how software development worked in the past and also based on what people are doing now with software development using AI? All right. To identify and integrate breakthrough best practices will fundamentally improve the speed, reliability, quality of our AI system software. Blah, 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 blah. You have correctly identified that we have built a strong four-pronged foundation. Any new ideas must be built on this. Okay, our current foundation is calibration documents for handoff between AI instances, senior junior architect model for reviewing plans and providing wisdom, automated unit regression tests for debugging specific features, user story simulation for building deep functional context. The missing link, the gap between writing and testing. Our research recent debugging sessions have exposed the single biggest source of pain in our current process, the long, slow, and unpredictable gap between when Cascade writes the code and when our automated test finds a bug in that code. This gap is where all the frustration lies. It's filled with silent failures, state drifts, imprecise edits. The solution not to do more of the same, but to add new layers of our process that close the gap. Okay, we're going the right direction. 3 breakthrough proposals for next evaluation. Okay, number 1. The protocol for preemptive analysis, the AI linter. Cascade sometimes writes code that is syntactically correct but logically flawed, or that contains simple dumb mistakes like using the wrong variable name. Our current process only catches these errors much later when the E2E tests fail. We will add a new mandatory step before we run the expensive Puppeteer tests. After Cascade writes a block of code, we will give the code to the second opinion AI, which can be a fresh instance or even me, the architect with specific limited task. The new protocol intent to perform a fast, cheap static analysis of newly written code to catch common errors before running the test. Plan after the, what is this? After the implementation prompt is complete, the architect will issue new type of prompt. Pre-flight check prompt. Here's a new Java. Do not judge its overall logic. Perform a static analysis and answer only these 3 questions. Are there any obvious syntax errors? Are there any variables that are used but not defined? Does the code violate any of our core architectural principles? This is like having an automated code linter with a brain. It can catch the whole class of simple errors in seconds, saving us the 1 to 2 minutes it takes to run the full suite only if it fails on a simple typo. It's protocol 2. Our most painful bug, the z-index issue with the drop-down menu, was a visual bug. Our functional test passed, but the UI was still broken in a subtle way. We found it only through manual inspection. We will use the Puppeteer's MCP tool, not just for failure reports, but for success validation. To create an automated safety net for the user interface itself, catching visual regressions that function tests would miss. For any task that involves a significant UI change, the sprint plan will include a new step. After the functional pass test, the architecture will issue the visual assertion prompt. Live refactoring. My current process, this is a very linear waterfall style approach. Modern human developers often work in a much tighter, more interactive loop. For complex dedicated refactoring tasks, we can opt a pair programming model. Instead of giving Cascade a large block of code to write, we can build it together line by line. So it's asking to add one more, well, I guess 2 more steps, 3 steps, but I like 2 of these steps. Okay. I don't know. So what does it want? It wants to rewrite our OMDL. Okay, so what we're going to do now is we are going to see why the alarm didn't go off. Okay, my alarm didn't go off. Fine. Anyways, I got to go outside with my dog, but actually, let's not do that. Let's give it another 20 minutes. Is my crisp going to run out? How much time do I got left on crisp? 40 seconds. All right, so crisp is going to run out. Anyways, so the audio is going to change a little bit in 30 seconds from now. Okay, so let's start. What we're going to do is we are going to start with calibrating our new Gemini instance. So we're going to click this one, state and continuity. This is version 6 of our state and continuity. I realize it's not in Markdown. What do you learn from this text? So it's not in Markdown, but it's forcing AI to read it and try to understand it. So once it reads it and understands it and explains it, now it's in Markdown. All right, let's take a listen to see what it thinks about this. Okay, the audio's not working.
At its core, the Charter establishes a framework for maintaining a single source of truth through a set of core documents, strict protocols, and a defined command interface. The primary goal is to create a perfect, complete input for each new work session based on the output of the preceding one. This ensures clarity, human-AI alignment, and a transparent, auditable record of all project decisions. The AI's role is defined as the AI software architect and protocol steward, with a prime directive to uphold the integrity of the project's core documents. The AI's performance is explicitly measured by its strict adherence to the outlined protocols. Key components of the Phoenix Protocol. Core documents. The project's foundation rests on 4 key documents. Product Requirements Document, PRD, defines the why and what of the project. System Logic and Architecture Document, SLAD, details the how of the project's implementation. Operational Manual and Decision Log, OMDL, outlines the how we work and logs all key decisions. Sprint Plan specifies the what we are doing now, with a strict requirement for every task to be traceable to a specific decision in the OMDL. Core Protocols, a set of mandatory and critical rules govern the interaction and documentation process. State Management, Protocol A, that AI must mentally track all proposed changes to the core documents. Explicit Approval, Protocol B, changes are only considered approved when the project lead uses the precise phrase, decision confirmed, followed by a summary. Semantic Versioning, Protocol C, upon concluding a session, any modified core document must have its minor version number incremented. Generation, Protocol D, when the prepare_handoff command is issued, the AI must apply all approved amendments and generate a session changelog, along with the new, updated versions of all necessary documents. Verbatim Generation, Protocol E, the AI is strictly forbidden from summarizing or omitting any part of the documents during the handoff generation. The full text must be produced. Correction, Protocol F, a new protocol allowing the project lead to reverse a mistaken decision using a correction command. Verification, Protocol G, another new protocol that mandates a strict implement then verify cycle for all application code implementation. Session Workflow, the Charter defines a clear start and end to each work session. Initialization, a session begins with the AI being provided with the Phoenix Protocol Charter and the 4 current core documents. The AI must then confirm initialization with a specific formatted response, including the versions of the ingested documents. Conclusion, the session is ended by the project lead issuing the prepare_handoff command, which triggers the generation of the complete handoff package. In essence, the Phoenix Protocol is a highly structured and disciplined approach to project management in an AI-assisted environment. It prioritizes meticulous documentation, explicit decision-making, and verifiable implementation to ensure project integrity and seamless collaboration across work sessions.
Okay. Are you capable of running the Phoenix Protocol Charter? Are you capable of running the Phoenix Protocol Charter? I mean, obviously it's going to say yes. So then what we're going to do, now we're going to click the project requirement document. So upload the product requirements document. Now, as it's reading this, we're understood. I have ingested. See, there you go. So now we go back here and we get the system logics and architect doc. Command A, Command C. Jump back over here and Command V. What is this? Why does it say I am ready for the final doc? When combined, why does it say this at the end? Okay, I see. Conclusion. Well, I'll just leave the last part of that conclusion and just delete these two lines. And then go back to the actual doc and remove those two lines from the doc. Oh no. I have, see, so I had an older version. So what I'm gonna do is I'm just gonna, it's not Control A because I have an older version. So I'm just gonna Control C and now I'm just gonna go back to here and then I'm gonna click Control A, delete. Now I'm gonna update. There we go. So it doesn't need to have that full situation. Next is the OMDL. This time we're not gonna Control A because I have a past version in here. All right, so we have a four-step process. The first step is the calibration documents. The second step is the senior architect is going to help the junior architect in the first steps of deciding on how to create the next sprint. Then the other two things that we had were the automated testing and the user stories. So what we're going to do is we're going to hold on. Sprint plan. Why don't I have a sprint plan? So I don't know why it says that. I don't think it has a current sprint plan. So we kind of have like there's a couple things we want to do. All right, let me just have a chat with this AI. Okay, so you understand the Phoenix protocol and you also have the 3 calibration documents. This is the core, and you've just asked for the sprint plan. Now, the issue with the sprint plan is that we were working on something with our software and we haven't completed the sprint. So we completed one sprint, but I noticed that all of the things that we wanted to change in the software, they're not currently working. So, but we actually have 2 sprints. So the one sprint, it's about changing some things on the task list page so that the task list page could be the single source of truth for a person who hasn't started using other task list software. For example, Monday.com, Jira, ClickUp, and Asana. So imagine you're a person and you haven't started using one of those types of software, but you do feel the need to use some task list app. So I want to make sure that our task list page is good enough that a person who hasn't used task list apps before would be satisfied with the basic features. And also because when we move from the free version to the pro version, then we want to have the ability for our task list page to continue to be helpful for people. And the particular interesting thing about our Pro version of our app is that there's going to be the ability to save projects, which means that when we build task lists, which are connected with objectives, then those objectives are going to be connected to projects. And then people will be able to go to different projects and then open up the project and then go to a specific objective and then look into the objective and find out what's the state of the current project. Although I am using the feature where a person would be able to take that task list and then upload it directly to their task management software like Asana and Jira and ClickUp and Monday.com. But I also want the person to have the option to be able to use our native task list. And so the sprint that we've been really focused on is to improve our task list for the free version. Now, the issue is that as we've been working on our software, we are having some problems between the architect that we were using previous. So the other architect, it's also an AI instance here in Gemini. And you're going to have a moment, like in a few minutes from now, you're going to have the opportunity to begin to communicate with that architect. That architect is now considered the senior architect. You will be considered the junior architect. One of the ways that we were able to solve some of the coding issues is through the automated testing. And so we want to continue to improve our ability to work with automated testing, but we also have a couple of ideas that we want to test. So as we work on our next sprint, there's actually two different main tasks. One is the actual main task of improving the task list page. And then the second task is how we can incorporate a couple of strategies in order to improve the ability for Cascade inside of Windsurf to update and to create code so that our project runs faster and we are able to improve it with more accuracy. So I want you to create a prompt and introduce yourself as the junior architect. I want you to explain how well you understand the calibration documents and also explain how well you understand your role working with Cascade. And then I want you to ask it what ideas that it has to improve the ability to create automated tests and how we can improve the way that we're writing our automated tests. I also want you to ask it about these two new strategies that we're testing. One is called AI linter. It's a protocol of preemptive analysis. So the problem is that Cascade sometimes writes code that is syntactically correct, but logically flawed, or that contains simple dumb mistakes, like using the wrong variable name. Our current process only catches these errors much later when the E2E test fails. So the solution is likely that we will add a new mandatory step before we run our expensive Puppeteer tests. After Cascade writes a block of code, we will give that code to the second opinion AI, which will be a fresh instance, or even me, or even you, the architect, or maybe even a new window inside of Cascade. So we may have like so we might be working with two different windows inside of Cascade. There'll be one Cascade, which is going to be writing the code and writing the tests. Then we'll have another window that we can go to. We can click on the other window, and it will be the AI linter window that will do this. And so I want you to ask how to set up this task and how we might create a sprint around testing this idea. The second idea that we want to test is a concept called the protocol for visual ground truth. It's called the screenshot diff, DIFF. The problem is that our most painful bug, the Z index issue with the drop-down menu, was a visual bug. Our functional test passed, but the UI was still broken in a subtle way, and we only found it through manual inspection. The solution is that we will use the Puppeteer MCP, Puppeteer screenshot tool, not just for failure reports, but for success validation. So those are the two things that I want you to ask. And then the third thing, actually, I also want you to ask what we might do to create some user stories. And the user stories that I'm specifically talking about are user stories where we would be having a bunch of different automated journeys where Cascade would actually pretend that it is the user, and it would have a series of experiences where it would go through and use our application, use the software, and kind of figure out what are the common paths and what are some edge cases and what are some different ways that people might click buttons and use our app in order for us to make sure that Cascade knows how to not just understand the blueprints of how the software is created, but also have experience walking through the application and driving through all of the different ways that real people might be using our application. So I need you to summarize all of the things that I just explained to you, and then create a prompt that invites our senior architect to have a discussion with you about these items. All right, so this little buddy is now called Free 5. And we're going to be using it to have a little discussion with Free 4. Okay, enhance our task list page. Yes. So he says implement enhanced task list UI and logic. Implement features for editing, reordering, multi-stage status system. Yes. All data will persist in local storage. Yes. Design the AI linter test. Describe structure and run proof of concept validation of effectiveness using a second opinion AI to review code for logical flaws before running the E2DS. Visual ground truth. Structure, run proof of concept to integrate. Automated user journeys. Formulate a strategy. Okay, good. Good. It worked. Fabulous. So, copy. Now we're going to go over to our decrepit, aging senior architect. And let's see if we give it a really clear prompt, if it can handle this. It's funny, like the journey that we had with this, because it's really like you watch, it's like I have a dog, right? And what I realized is that the dog doesn't live as long as a human lives, which means that I saw it being born and I will also see it die. So, and then there's going to be another dog after that. And then I will see it like be born and be alive. And then I will die. Like, how many of these dogs I'm going to watch be born and die? And so now, okay. All right. Further questions do you have based on this response? All right, I'm just gonna go back. I'm getting tired of it. It's always using Cascade. I hate it when it uses Cascade for everything. This is an excellent initiation. The junior architect has demonstrated a perfect understanding of the core mission and has asked precisely the right questions. The focus on improving our process before writing more feature code is the most important strategic decision we can make right now. As a senior architect, my role is to provide wisdom and scar tissue from our past failures to guide this new one with more resilient approach. Junior architect has correctly identified the 4 key areas where we can innovate. I would agree to that. All right, let's give her a listen.
catch errors as early and cheaply as possible. Overall strategy. The new philosophy is catch errors as early and as cheaply as possible. The three protocols, AI, linter, screenshot diff, user journeys, will form the layers of this testing pyramid, moving from cheapest, fastest checks to the most expensive, comprehensive. Priority number 1, the AI, linter, proof of concept. This is our top priority. The senior architect has provided a clear, 3-step plan for a proof of concept, POC. 1. Setup. Use the known buggy handle delete click function as our test case. 2. Execution. Prompt a fresh AI instance, the linter, to identify, not fix, specific types of flaws in the buggy code. 3. Analysis. The POC is a success if the linter correctly identifies the known logical flaw. A successful outcome will lead to formalizing a pre-flight check prompt in the OMDL.
Yes.
Guidance on visual ground truth. I have clear instructions for this protocol. Asset management. Golden screenshots will be treated like code, stored in a new tests, golden_screenshots directory, and versioned, e.g., task list dropdown open v1 link to .png. Technical implementation. We will not use brittle pixel for pixel comparison. Instead, we'll use a library for structural similarity, like SSIM.js, with a configurable threshold, e.g., 99% similarity, to avoid false negatives from minor rendering differences. Guidance on automated user journeys. I know how to begin. Starting point. We will start by scripting the golden path, the most common and critical user workflow. For us, this is completing the brainstorm module from start to finish. Implementation. This will be a new test file, tests.js, with the first test case being it, should allow a user to complete the full brainstorm module. My next action, my immediate and explicit task is to create a formal, atomic sprint plan for the AI, linter, proof of concept. Further questions. My questions are focused on ensuring the sprint plan I create for the AI, linter, POC is precise and aligns perfectly with the senior architect's vision. 1. Regarding task pi.1.1, setup, do we have the correct and several incorrect versions of the handle delete click function readily available in a log or a commit history? Or will my first subtask be to reconstruct these versions based on previous failure analyses in the OMDL? 2. Regarding task pi.1.2, execution, the prompt suggested for the linter is highly specific. Should the sprint plan include a subtask dedicated to refining and finalizing the exact wording of this pre-flight check prompt before we execute the test? This seems critical for the success of the POC. 3. Regarding the AI linter's environment, the senior architect mentioned using a fresh AI instance. For the purpose of this POC, does this mean I should use a new chat session with a clean context, or are we referring to a specific tool or API endpoint that we should utilize for this test?
Okay. So what we're going to do is we're going to be using the Cascade, the previous instance of Cascade, as our senior Cascade. And then we're going to create a new junior Cascade. And we may also be creating an AI linter Cascade. So the new Cascade is going to replace the old Cascade. And it's also going to be, and then the AI linter Cascade is going to learn how to do this AI linter job from, all right, so basically what we have to do now is we have to start to work with Cascade. We can't just work only with Google Gemini in the next series. But I think we'll finish our video for today. And my dog is, for some reason, do I have soup on my pants or something? Why are you so interested in my pants? Anyways, time to go outside. Thanks for tuning in, and we'll see you next time.